Hey everyone, welcome back to Cracking the GRE Math Subject Test, Calculus 1. We're on question number 44. This is a good question to check your knowledge of the convergence tests for series. So the first, we're asked which of these statements is true. So the first statement says that if we have a series of where each term is positive and the series converges, then the square root of the series of the square root of the terms also converges. This is not true, and you can provide a pretty clear counterexample with if you let the a(n)s equal 1 over n squared. We know that this series converges. It's the p series with p equals 2. And we know that as long as p is greater than 1, then the series converges. But if we take square root of a(n), we'll end up with 1 over n, which is the harmonic series, and that does not converge, because, or we could say that it's a p series with p equal to 1, so that's not going to converge. So 1 is not true. Okay, so that's 1. And 2 says that if a(n) is greater than or equal to 0 and the series nan converges, then the series an converges. And this is true because of the comparison test. We know that the sequence an is going to be less than or equal to nan for all n. So by the comparison test, this statement is true. And for the third one, that might be the hardest one or the trickiest one. We're told that the a(n)s are positive, they're greater than 0, and this a(n) plus 1 less than or equal to a(n) means that they're monotonically decreasing. In other words, each term is less than the previous one. And then we're asked, is it true that if the square of the terms converges, then the series of the square of the terms converges, then this is called the alternating series also converges? Well, there's a theorem for alternating series. The theorem says that if the terms, if you take the terms themselves, the a(n)s, and they're monotonically decreasing, which we know that they are because we're told that, and that the limit of the terms is 0, then the series has to converge. Well, is the limit 0? If we know that this a(n) squared series converges, that implies that the terms approach 0 as n goes to infinity, which means that the limit as n goes to infinity of the a(n)s themselves also has to go to 0. So this fact, together with the fact that the sequence is monotonically decreasing, implies that the alternating series converges, and that's only for alternating series. If it wasn't alternating, then we wouldn't know that it converges. So this is true. And so our answer is 2 and 3 only, which is D.